Welcome back to my video series working through the Sonic Pi tutorial. In this video, section 8.4, Rings. Rings. An interesting spin on standard lists are rings. If you know some programming, you might have come across ring buffers or ring arrays. Here we'll just go for ring, it's short and simple. In the previous section on lists, we saw how we could fetch elements out of them by using the indexing mechanism. Put S 52, 55, 59, index 1. Now what happens if we want index 100? Well, there's clearly no element at index 100, as the list has only 3 elements in it. So Sonic Pi will return you nil, which means nothing. However, consider you have a counter such as the current beat, which continually increases. Let's create our counter and our list. Counter equals 0, notes equal 52, 55, 59. We can now use our counter to access a note in the list. Put S notes at counter. Great, we got 52. We'll run that. There's 52 up there. Now let's increment our counter and get another note. Counter equals inc counter put S notes of counter. I think I see where this is going. 52 and 55. Super, we now get 55, and if we do it again, we get 59. However, if we do it again, we'll run out of numbers in our list and get nil. Let's just try that. Yep, 52, 55, inc, nil. What if we wanted to just loop back around and start at the beginning of the list again? That's what rings are for. Creating rings. We can create a ring in one of two ways. Either we use the ring function with the elements of the ring as parameters, so like parenthesis ring 52, 55, 59. Or we can take a normal list, 52, 55, 59, and convert it to a ring by sending it to the .ring message. Indexing rings. Once we have a ring, we can use it in exactly the same way you would use a normal list, with the exception that you can use indexes that are negative or larger than the size of the ring, and they'll wrap around to always point at one of the ring's elements. So I may not type out all of this. Yeah, I'll type it all up. No, I won't. Ring 52, 55, 59. At position 0, we get 52. At 1, we get 55. At 2, we get 59. At 3, we loop back around and get 52. At -1, we loop around the other direction and get 59. Using rings. Let's say we're using a variable to represent the current beat number. We can use this as an index into our ring to fetch notes to play, or release times, or anything useful we've stored in our ring, regardless of the beat number we're currently on. Scales and chords are rings. A useful thing to know is that lists returned by scale and chord are also rings and allow you to access them with arbitrary indexes. Ring constructors. In addition to ring, there are a number of other functions which will construct a ring for us. Range invites you to specify a starting point and step size. Bools allows you to use ones and zeros to succinctly represent booleans. Knit allows you to knit a sequence of repeating values. Spread creates a ring of bools with a Euclidean distribution. Take a look at their respective documentation for more information. Well, I may have to save that for another video. Thanks for watching.